Our next example, working with integration by parts, is the antiderivative of sine inverse, and hence from this we can get the antiderivative of really all the inverse trig functions using this similar technique. So the same thing happens with sine inverse that happened in the previous example we talked about, dealing with natural log. This is a function which is the product of two functions. It's the product of 1 times sine inverse of x, or arc sine. If you prefer arc sine, you can be writing arc sine here. But this is 1 times sine inverse of x, and this is a transcendental function times another function. And so we're going to try parts with this. Well, dv, let dv, choose dv to be the most complicated portion whose antiderivative you know. Well, we don't know the integral of sine inverse, otherwise we'd be dead. We'd be done by now. Now, what I want to do is remind us, remember from our glory days in Calc 1, that we do know the derivative of sine inverse. The derivative of sine inverse is 1 over square root of 1 minus x squared. So we do know the derivative of sine inverse. What we don't yet know is the antiderivative of sine inverse. And so the most complicated portion whose antiderivative we can find is 1. Everything else is u. The derivative of u is the derivative of sine inverse of x, which is, as we just said here, 1 over the square root of 1 minus x squared. Yeah? And the antiderivative of 1 is x. Reattach the variable. So now we have all the parts. Let's reassemble them. uv minus integral v du. uv, that portion is finished. That's x sine inverse of x. But now we need the integral of v du. So that's x times this fraction. I'm going to put the x in the numerator. So that's x times this function, top times top, bottom times bottom. And so we end up having to compute this integral. Now, this integral is not brutally difficult. This is a Calc 1 integral. That's an ordinary U substitution because we notice we have degree 2 here, and this is degree 1. So I'm going to rewrite this as x sine inverse of x minus, and then I'm going to rewrite this as x times 1 minus x squared to the negative 1/2 power. I'm going to use exponential form here, and this is an ordinary garden variety U substitution. So what I'm going to do here is I'm going to remove this piece. I'm going to leave this alone, remove this piece. Just going to work with this piece, leave the negative sign out even. All right, I'm going to leave just this piece, and so I'm going to say the integral of x 1 minus x squared to the negative 1/2 dx. This is an ordinary garden variety U substitution. In fact, what you ought to do now, pause the video, see if you can work that the rest of the way out, and then when you come back in, I'll work it out and see if I can match what you developed. So hopefully you were able to work that out. Let's see if I can match what you did here. This is an ordinary Calc 1 U substitution. Let u equal 1 minus x squared. du is negative 2x dx. I don't want negative 2x dx. I need to get rid of the negative 2. So that implies negative 1/2 du is equal to x dx. And the substitution is exact. And so what we generate from that, that's equal to negative 1/2. X dx is negative 1/2 du. And quantity to the negative 1/2 is u to the negative 1/2. And that's the ordinary power rule. This is negative 1/2 times u, raise this, add 1 to the exponent. So that's positive 1/2. Divide by 1/2 is the same thing as multiply by 2. And so the 2's cancel. This is negative. What was u to begin with? U to begin with was 1 minus x squared to the 1/2. And this has a negative sign with it. So this is this integral. Notice this negative sign is still here, this negative sign is still here, and so the result is, so we have this piece, the x sine inverse, minus negative becomes positive, and then we have, you may write this with the square root or the 1/2 power, it doesn't matter. And so that's the antiderivative of sine inverse. Almost certainly you're not going to have that memorized. I know I certainly don't. But anytime you need the antiderivative of sine inverse or any of the inverse trig functions, you would go through an exactly similar development to this, and you should be able to work that because now you know how to work integration by parts.